Do you know in business, it's always been difficult to set the right price for goods or services. Everything is dynamically priced these days, whether it's a movie ticket, a flight ticket, a hotel room, or a cab fare. Predictive analytics is a common tool businesses use to target customers and improve operational outcomes. Predictive analytics is widely used in various industries like marketing, manufacturing, real estate, healthcare, and many more. In order to predict future outcomes using regression analysis, forecasting consumer behavior is the best use case for the predictive analytics using regression analysis model in the real world. Hey everyone, I am Mayank from Simplilearn. In this video, we will learn what is machine learning, followed by machine learning types. We will continue this session by understanding what is supervised learning, followed by its types. Moving forward, we will look at what is regression analysis. We will continue this session by understanding why we need regression analysis. After that, we will look at the advantages and disadvantages of different types of regression analysis models. Further, we will also see some popular regression analysis algorithms in detail, followed by application of regression analysis. After discussing regression algorithms, we will see a hands-on lab demo using Olympic 2022 dataset and how regression algorithms work. At last, we will end this video by discussing job opportunities in regression analysis. But before we begin, if you haven't subscribed to our channel, hit the subscribe button and please don't forget to press the bell icon so you will never miss any update from Simplilearn. Also, if you are willing to upskill yourself in machine learning, check out our free course on machine learning by SkillUp. Check the link in the description below. So, without any further ado, let's begin. Machine learning is a subpart of artificial intelligence, the art of making computers learn and act like human by feeding data and making prediction based on experience. For example, by using ML algorithms, you can determine the quickest route with the least amount of traffic, arrival time, the pickup location, and the best optimal path to the destination. Machine learning is classified as supervised learning, unsupervised learning, reinforcement learning, semi supervised learning. After understanding what is machine learning and its type, let's understand what is supervised machine learning. In supervised machine learning, machines are trained using labeled data, also known as training data, to predict results. Here, labeled data refers to a group of data tagged with one or more names, and the data is already known to the machine. In the real world, supervised machine learning can be used for image and object recognition, predictive analytics, customer sentiment analysis, spam detection, and many more. Supervised machine learning can be further classified into two problems, which are classification and regression. Let's quickly understand them one by one. Classification is a process in which new observations are recognized and separated in such a way that they can be categorized. A classification algorithm is trained to identify the spam emails by studying the difference between spam and non-spam email. A function that converts an email text into a categorization for spam could serve as a classification model or non-spam classification. There are some popular classification algorithms that come under supervised machine learning are random forest, decision tree, logistic regression, k nearest neighbors, and many more. The next one we have is regression. A regression algorithm is used to find out the connection between dependent and independent variables. Dependent variables are nothing but a variable that we are trying to predict or forecast, and independent variables are the factors that influence the analysis. It is usually used to make projections. Medical researchers frequently utilize linear regression to study the connection between patient blood pressure and dosage. Researchers may give patients different quantities of a specific medication and track how their blood pressure changes. A regression model might use dosage as a predictor variable and blood pressure as a response variable. There are some popular regression algorithms that come under supervised machine learning. First one is linear regression, regression trees, nonlinear regression, Bayesian linear regression. After discussing what is supervised learning and its types, let's move forward to see what actually regression analysis is. A stat technique known as regression analysis is used to simulate the relationship between dependent and independent variables using one or more independent variables. Regression analysis more precisely enables us to comprehend and when other independent variables are held constant. Changes in the dependent variable's value that correspond to an independent variables are changing. Prediction include values that are continuous or real, such as temperature, age, pay, and cost. There are some following concepts or terminologies that must be understood in order to completely grasp regression analysis. The first one is dependent variable. In a regression analysis, the primary variable we wish to predict or comprehend is the dependent variable. Here, dependent variables are also known as target variable. The next one is independent variable. The term independent variables, also known as predictor, refers to the elements that impact the dependent variables or are used to forecast their values. And the third one is outliers. An observation that is extremely high or extremely low in relation to the other observed values is referred as an outlier. An outlier should be avoided as it might affect the outcomes. The fourth one is multicollinearity. The situation is said to as occurring when independent variables have a higher correlation with one another than other variables. It shouldn't be included in the dataset because it causes issues when determining which variable has the greatest impact. And the fifth one is overfitting and underfitting. Overfitting is the problem that occurs when our system problems well with the training dataset but poorly with the test dataset. Underfitting is the term used when an algorithm does not perform well even with the training dataset. After understanding what regression analysis is and its terminologies, let's move forward and see why we use regression analysis, including those involving the weather, sales, marketing trends, and other factors. In this situation, we need regression analysis that can make forecasts more precisely. So let's understand the concept of regression analysis using an example. Business frequently use linear regression to understand the relationship between advertising spending and income. For instance, they might run a simple linear model with advertising as a response variable and revenue as a predictor variable. The regression model would look like this. Revenue equals to beta 0 plus b1 ad spending. Where there are no advertising, the coefficient 0 would indicate the whole expected revenue. When advertising expenditures are increased by 1 unit, coefficient will represent the typical change in the total revenue, that is $1. If beta 1 is negative, then higher advertising expenditures will result in lower revenue. If beta 1 is nearly 0, advertising expenditures have little impact on revenue. And if beta 1 is positive, it would imply that more advertising expenditures are linked to higher income. The amount of beta 1 will determine whether a corporation decides to or decrease its advertising budget. Regression means creating a graph that connects variable the best fit the given data point. The regression analysis model can then make prediction about data using the plot. Regression analysis is defined as showing a line or a curve that goes through all the data points on the target predictive graph in such a way that vertical distance between the data points and the regression is smallest. Whether a model has captured a strong link between determined by the distance between data points and the line. There are some more use cases of regression analysis like we can use temperature, another variable to predict or forecast rain. Regression analysis can be used for identification of market trends. For predicting traffic accidents caused by reckless driving, we can use regression analysis for the same and many more. So, by understanding why we need regression analysis, moving forward, let's see some popular regression algorithms in detail. The first one is linear regression. Linear regression is one of the most famous and straightforward machine learning algorithms utilized for predictive analysis. Linear regression shows the linear connection between dependent and independent factors. The line of the equation is y equals to mx plus b. Here, y stands for the response variable or a dependent variable, whether x is for the predictor variable or an independent variable. Here, m is the estimated slope and b is for the estimated intercept. And the next one is regression trees. A regression tree is worked through a cycle known as binary recursive, which is iterative interaction that divides the information into segments or branches, and afterward keep splitting the data into smaller groups. As the technique climbs each branch, this tree is used for the dependent variable which continuous values. For example, a regression tree is name food which is divided into segments, veg and non-veg. Further, it keeps splitting into smaller groups. And the third one is nonlinear regression. Nonlinear regression is a type of regression examination wherein information is to fit a model and afterward communicated with a numerical function. Simple linear regression relates two factors x and y with a straight line y equals to mx plus b, while nonlinear regression relates the two factors in a nonlinear relationship. Nonlinear regression can be predict population growth over time or the relationship between GDP and a country's time. And the fourth one is Bayesian linear regression. The algorithm is a way to deal with a linear regression in which statistical examination is attempted inside the setting of Bayesian inference. Linear regression and Bayesian regression can generate the same prediction, and with the help of Bayesian processing, we can retrieve the complete variety of inferential solution instead of a point estimate. After seeing some regression analysis algorithm, let's move forward and see advantages and disadvantages of different regression analysis models. And the first model is linear regression model. The advantages are work well irrespective of dataset size. And the second one is gives information about the relevance of features. And the disadvantages are the assumptions of linear regression. And the next one is polynomial regression. The advantages are works on any size of the dataset. And the second one is works very well on non-linear problems. And disadvantages are we need to choose the right polynomial degree for the variance trade-off. The next one is support vector regression algorithms. And the advantages are easily adaptable, works very well on non-linear problems. And disadvantages are difficult to understand and not well known. And the next one is decision tree regression. The advantages of decision trees are no need to apply scaling. And the second one is works very well on both linear and non-linear problems. And disadvantages are poor results on a small dataset and overfitting can easily occur. And the last one is random forest regression. The advantages are powerful and second one is accurate. And disadvantages are no interpretability and the second one is overfitting can easily occur. After seeing advantages and disadvantages of different types of regression analysis model, let's move forward and see some applications of regression analysis. The first one is forecasting. Regression analysis is frequently used in business to predict potential opportunities and dangers. For example, demand analysis predicts how many items a buyer is likely to purchase. Demand, however, is not only the dependent variables when it comes to business. Much more than just direct income can be predicted using regression analysis. And the second one is CAPM, Capital Asset Pricing Model. The linear regression model is a key component of the capital asset pricing model, CAPM, which determines the relationship between an asset expected return and the associated market risk premium. Financial analysts typically use it for forecast corporate return and operational performance when doing financial analysis. And the third one is comparing with competition. It can be used to evaluate how well a business is doing financially in comparison to a certain rival. It can also be used to figure out how the stock prices of two companies are related to one another. This can be extended to find the correlation between two competing companies. It might help the company identifying the factors affecting the sales in contrast to the comparable company. These methods can help small business succeed quickly within a short period of time. And the last one is identifying problem. Regression is a beneficial for identifying incorrect judgment as well as for providing factual support for the management. For instance, a retail store manager might believe that extending the hours of operation will greatly increase sales. After seeing application of regression analysis, let's understand the regression analysis using the code. So now we will see hands-on lab demo using Olympic dataset 2022. So we will use support vector machine. A support vector machine is a well-known supervised machine learning model. It is utilized for both information, classification and regression. It is regularly utilized for the grouping issues. Let's open Jupyter Notebook. So this is our command prompt and here we will write Jupyter Notebook to open Jupyter Notebook. So press enter. So this is the landing page of Jupyter Notebook and here we will open one Python file. So this is how the Jupyter Notebook UI looks like. So at first we will import some major libraries of Python which will help us in mathematical functioning. So the first one is NumPy. So we will write import NumPy as NP and press enter. So NumPy is a Python library used for working with arrays. It also has function for working in the domain of linear algebra and matrices. It is an open source project and you can use it freely. So NumPy stands for numerical Python. So we will import the next library as pandas. So we will write import pandas as pd. So pandas is a software library written on Python programming language for data manipulation and analysis. In particular, it offers data structure and operation for manipulating numerical tables and time series. So, so after importing the libraries, we will move forward and import dataset. So for importing dataset, we have to write data equals to pd dot read underscore csv. So here we have to write our dataset name Olympics 2022 so O is capital in my file, so I don't know what's going on. Yeah, perfect. So press enter. So here PD is for pandas library, read is used for the reading the dataset from the machine, and CSV is used for the type of file which you want to read. So then we have to write data to see our data. So press enter. So this is how our data set look like. So for separating data like in a proper row and column, so we can use here SEP equals to this semicolon. So after this enter, so this is how our data look like. So this is 91 rows and 27 columns data. So so moving ahead, we will replace NA's values like these NA's values from 0. So we will write here. So we will write here data equals to data dot fill NA value equals to 0. So after entering, we will write here data and press enter. Now see, just we have replaced all NA's with zeros for better results. See, all zeros with NA's here and no NA's here. Moving ahead, now let's see how our data look like in pie chart. So we will write import some matplotlib libraries. So we will write import matplotlib dot pyplot as plt. So matplotlib is a graph plotting library in Python that serves as a visualization utility. Matplotlib is a open source and we can use it freely. And it is mostly written in Python. A few segments are written in C and JavaScript for platform compatibility. So we will write here some male athletes. Oh, athletes. I guess athletes. Sorry for that. Athletes equals to data square brackets. We have to write men a capital athletes. So dot sum. So after entering, we have to write sum score email underscore athletes was to data square bracket open. We have to write here. We can write here woman athletes dot sum. So we have to write here figure comma ax equals to plt dot subplots. So we have to write here figure size. Oh, sorry. Figure size size equals to, we can here give 12 comma 6. So here subplots, a subplot is a secondary strand of the plot that is a supporting side story for any story or the for the main story. So we will write here ax dot pie for the pie chart, and sum underscore male underscore athletes, comma, we'll write here sum underscore female underscore athletes, square bracket, comma, text props equals to DSCT for the color of woman equals to W. So after entering, we have to give here legends a dot legend uh, underscore men. This is for men, comma, and woman. So comma, so LOC equals to upper right, comma, title equals to gender, comma, maybe OX underscore to anchor. This is for just the change equals to, we have to give here 1 comma 0 comma 0.5 comma we are okay 1. So let's keep it like this. So we will write here ax dot set title. So here we can give title like total proportion of male and female athletes. So after this we can write plt dot show. We can here write plt dot show, and we will see now how our pie chart look like. So this is how our pie chart look like. So moving ahead, let's see one more visualization data with bar graph. So we will write here countries equals to data NOC. You have to just write in. So we will write here men underscore athlete equals to data. So we will write here men athletes. So women underscore athletes equals to data. Women athletes. Here we will write int equals to np dot arrange. So we have to give here length. len. So countries okay into, we will write 32 here. So width we will give maximum width we will give 8. So it's your wish how much you will give. So here we will write figure comma ax equals to plt dot subplots figure size equals to 64 comma 16. So we will write ax dot bar because we are creating bar chart here. So we will write ind. This is width slash 2 comma man athletes comma width equals to we will write here width again equals to man. Perfect. So here again we will write ax dot bar ind plus width divided by 2 comma men athletes. So we will write here not men, this time we have to write woman. So we will write comma, we will give width equals to width comma label equals to woman. So here we will write ax dot set. We have to set the y label and the x label. So first we will write for the y label. So y label. So this is like amount comma font size equals to 40. So ax dot set title. We will write the title, but we will give like title like male and female athletes from, like we can use different countries. So comma font size equals to we will write chalo 50. So like this. So let's set the x labels to underscore label, sorry, x label. So here we will write countries size equals to 40. So ax dot set underscore x ticks ind. So we will write here ax dot set underscore x ticks. Not ticks, we have to write only tick. So labels trees comma font size equals to 20. So ax dot legend crop equals to size. Okay, we have to give size like this. 30. So we have to write plot plt dot acid setup ax dot get x pick labels and comma rotation equals to 45. So we will write here h equals to right and again comma rotation underscore mode equals to anchor. So finally the time has come to for the plot dot show. Sorry, this is not plot, this is plt dot show. So press enter, and so this is our bar graph how looks like for the how many countries here we take countries almost 32 countries. So this is our data for the 32 countries. So moving forward, let's train our data now. So set test equal to data bracket data. So here we will write total medals like equals to not equals to 0. So comma sample and equals to 5. So we will write train equals to data set. Not sorry data, only data we have to write data bracket data bracket. We have to write here total medals. Let's write the same. Here we will write drop drop. We will write drop test dot index. So here we have to write dot. So here we will write test for testing data and press enter. So this is our testing data. So this is how the data looks like. And now write for the train data. So we will write only train, then press enter. So this is our training data. So now we will import sklearn. So we will write. So like scikit-learn, sklearn is the most useful and the robust library for machine learning in Python. So it provides a selection of efficient tools for machine learning and statistical modeling, including classification and regression. So we will write import scipy like from sklearn dot svm is for support vector machine and import svr. So this is support vector regression. So we will write here from sklearn dot preprocessing. Preprocessing we have to write import standard scalar. So like we have to write here from sklearn dot model underscore selection import randomized search CV. Oh, C capital CV. So let's get the our train data and the test data. So we will write scalar equals to standard scalar, and here we will write our test label, score label equals to test NOC, right? Test underscore X equals to scalar. Okay, my bad. Scalar dot fit underscore transform test. Test here two brackets, and we will write athletes, so comma man, woman. So here we will write for the test y-axis equals to test gold silver comma, and the third one is bronze. Press enter. Train label, train NOC train underscore X equals to scalar dot fit. We have to write like this underscore transform for transforming the data. So we will write train same athletes athletes train underscore y equals to train train underscore y equals to train gold comma silver comma bronze perfect, and press enter. So now we will build our model. So we have to write SVR equals to SVR like this. PARMs for parameters equals to C. So here we will write scipy dot stats xp1 exponential for scale equals to 100. Okay, we will use gamma that colon scipy dot stats dot e so here we will write scale equals to 0.1 and okay, so here we will write comma and the last one we write kernel, so colon linear. So like this, so press enter. So iters equals to 50, rs gold equals to randomized search cv pr comma params comma and underscore iter equals to iters. Press enter, we will write rs for, we have to write for same for silver and the bronze, so we can copy here and we can paste here, again we can paste here. So we will just change here and here we have to write silver, here we have to write bronze. For this we have to write rs for gold dot fit, like now we will train underscore x label comma train underscore y. For this is we will do for the gold, so same we will train this for the this silver and bronze, so we can copy here from v control v, so just we will change here to silver here, bronze here, okay sorry, bronze here we will write bronze, silver, so here we will write y underscore gold underscore at equals to rs sorry underscore for gold dot prediction predict train underscore x. So again same for silver and bronze, so we will change it to silver we will write bronze, bronze. So let's move our screen a bit up. So here we will write print pd dot data frame, so list goes set zip here we will write mm, y underscore gold underscore hat y underscore silver comma hat Okay, I small, comma, y underscore bronze underscore hat. We will write here print uh, train underscore y dot reset underscore index drop equals to true here. So fig figure comma ax equals to test underscore y dot reset underscore index. So to write here test bad sorry for this we have to write plt dot subplots we will make 3 by 1. Okay, so here we have to write test underscore y equals to test underscore y dot reset underscore index I have done a small all this. So we will write here drop equals to true. So we will write here a0 for 0 axis dot plot. So y underscore gold underscore hat then again 0 sorry 0 and the color should be let's take green. Okay, so again ax 0 dot plot. So here we will write test. What is test data? Test underscore y square bracket. We have to write gold. Okay, so the color should be blue. Let's take blue here. So we will write blue and we have to make for the same for the silver and gold bronze sorry. So we can copy paste here and we can give the different axis name. This will be 2. So here we have to write 1, 2. Here we have to write silver. Okay, here silver 2. Here we have to write bronze. We have to write bronze. So the time is come. We have to write plt dot show. Now press enter. So after pressing, so our model. So this is how the SEM regression look like. So this is how we made regression analysis using SVM. So moving forward, let's see some job opportunities in regression analysis. An extremely potent statistical tool, regression analysis, can be used to get insight into customer behavior, corporate operation, and factor affecting profit. Businesses can use linear regression analysis to analyze trends and generate estimate or forecast. A product sale also be examined while using regression analysis. For example, McCain Erickson India Private Limited advertising company used linear regression to determine if the money spent on marketing or a certain brand resulted in a significant return on investment. The benefit of regression analysis is that it allows us to control the variables that can affect sales while also capturing the individual effect of each marketing effort. In the real world situation, several advertising campaigns are active at the same time. If two campaigns are broadcast simultaneously on radio and television, a regression analysis can capture both the individual and the combined effect of running these ads together. The commercial impact of regression analysis can really hold a huge potential to generate significantly high productivity growth. Currently, one of the fields with the greatest soul of growth is analysis. Analyst engineers are in high demand. There are various job profiles like data analyst, market research analyst, performance test developer, and many more who are hired with the skill of regression analysis and machine learning. The average salary of data analyst engineers in India is 6 lakh per annum, and the annual base pay for US and data analyst engineers is $69517. All ventures as of now have countless uses in regression analysis, which is the fundamental inspiration behind why there is an interest of occupation in that field. The growth in technology has led to increasing demand for the professional who can understand and use vast amount of data. Companies like Salesforce, Google, IBM, and many more are constantly hiring analyst engineers. I hope you guys found this video informative and helpful. If you have any doubts or feedback, feel free to leave them in comments below. We will be happy to help you. Machine learning is a trending field with a bright future if chosen as a career. Here is a machine learning certification course by Simplilearn to become a certified machine learning professional. Kindly check the course details from the link in the description below. If you like this video, please subscribe to our channel and don't forget to hit the bell icon. Thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.